Good morning. So today I'm going to present on the topic recent trends in artificial intelligence and its applications to power systems. Okay. So myself, Dr. R. Vijay, okay, Associate Professor, Department of EEE, CBR College of Engineering, Hyderabad. Okay, I'm working as an associate professor here. I'm acting as a okay. So here I'm acting as a MTech coordinator also. Okay. So here, we can go directly to the topic. Okay. This topic. Okay. So this artificial intelligence is like a very big ocean. Okay. So I'm going to just spray some small uh, portions for you. Okay. So even we can teach this subject even for the whole day also we can present. But so as far as the time concerned, so it is limited to some 1.5 hours. I'm trying to complete the maximum. Okay, so so today you can able to understand what is artificial intelligence. So how the in artificial intelligence, how the things are getting programmed. Okay, how it is communicating with the applications like that. I'm going to spray some small thing on you. Okay, so this might be useful for your doing your project also. Okay, so little bit little bit mathematics is needed. If you know your addition, subtraction, multiplication, then I think you can easily understand some few examples also. Okay, so I'm suggesting you to be with a pen and paper. Okay, small calculation we are going to do. Okay, to understand
Sir,
what is the problems and all. Yeah, tell me.
sir, voice is very low, sir.
My voice is very low. Yeah, now it is audible.
Well, sir, it's okay, sir. Now audible.
Yeah,
Proceed.
now it is audible. Yeah, you please tell me. Okay, anything is goes wrong. Okay. Okay. So next we'll go on to the topic. So power systems versus artificial intelligence. Okay. So you know what is an electric power system? So electric power system is a network of electric components. Network of electric components used to supply, transmit, and utilize the electric power. Okay. So what we are doing is it mainly deals with the generation, transmission, and distribution, and as well as the utilization of electric power, and other electrical devices. So mainly power systems engineering deals with these parts: generation, transmission, GTD, and also utilization of electric power. Okay, so how the artificial intelligence is playing a vital role. Okay, so nowadays everything is artificial intelligence only. Okay, so the artificial intelligence is known to be the intelligence exhibited by the machine and software. For example, robots and computer programs. Okay, so very good example of artificial intelligence is yeah, Google Maps. So what we are using Google Maps. Okay, so day by day we are using the Google Maps. Okay, so Google Maps did install any antennas or any communication stations throughout the world. Okay, the simple thing is that in the main places they have went for some 360-degree that photographs in the city centers. Okay, and then which are all the important places. Just like that, they went with a 360-degree photographs. Okay, that's all. And they know the nook and corner of the roads, all the roads in and around in the world. Okay, so then who is acting as a host? Who is acting as a receiving and sending station? Means ourselves only. So our mobile phones only. All our mobile phones, what we are doing is simply like that. We are just on the location. Okay, so we are only acting as a host. We are only acting as a receiver, sender for the Google Maps. Nobody, say for example, if I want to go to Kongunadu College from Tirchi bus stand. Okay, so say for example, the distance between these two is 10 kilometers. I need to travel by my car. Okay, so I'm putting the place in Google Maps. So it's showing some shortest route. Okay, so in which route I can avoid the toll roads, in which route is a very shortest route for very suitable for cars, something like that. So even any traffic, anything's happen in between. Okay, so who is telling? Okay, those who are there in that particular area is telling to the Google. It's communicating with the Google. So they are also went with some map. Okay, so in the same group. Okay, so they are telling in that particular app, like there is some traffic, or there is some accident in the particular in between the roads. Everything is being communicated. So traffic jam in that particular area. So everything is being communicated to the so Google routers by that cloud, Google Cloud. So by that we are getting the same data. Okay, so and also we are getting the speed also, speed of the vehicle also. Okay, so I'm traveling in 60 kilometer per hour, 100 kilometer per hour. Everything I can able to know. And also who is answering for you. Okay, like Google is some you are getting some voice. You can turn left in 100 meters, you can turn right. Okay, after 400 meters you take a U-turn, like that. Everything's they are telling. No, so nobody is sitting there. Okay, nobody is sitting there and telling you like you have to turn right. So everything is robots. Okay, artificial intelligence. Okay, so Google Maps is a very good example of artificial intelligence integrated with machine learning. Okay, so machine learning is second part after the artificial intelligence. So once you understand what is artificial intelligence, then this machine learning is very easy for you. Okay, so we are going to see something about the artificial intelligence techniques. Okay, so the term AI is generally used to developing system equipped with the intellectual process and characteristics of human life, the ability to think, reason, and find the meaning. Okay, so even if I'm just in a Google voice, I'm telling like so find the meaning of power system. So simply like that, it is searching. So my voice message is converted into text. Okay, so that is search into the Google. So there by it is updating the so the meaning. Okay, even that meaning is reading out, or so you can get it in the browser page. Okay, so like that, and also it is thinking. Okay, even so sometimes my accent may be somewhat different. Okay, so if I am staying in Tamil Nadu, so Tamil Nadu accent, English accent might be of something. So if you go to nearby state Kerala, so there may be some accent may be varied. Say for example, in Kerala they may tell like office. Okay, so even I'm inputting some word in Google. Okay, so office. So in that location, so Google is taking that word as office. Okay, so like that, if you go to some US, their accent may be of very different. So they will say like office. So some words. So even the accent also. Okay, so this this artificial intelligence can understand and able to get the solution. Even sometimes in the voice in the voice search you may get like can you repeat again, like that also so that robot is asking for us. Okay, so I can't understand, can you please repeat, like so, like that also you are getting some voice message in the Google search. Okay, see, this is a very good example of this artificial intelligence. Okay, so what is the need of AI? What is the need of artificial intelligence in power systems, especially in the power systems? Okay, so the subject like power system analysis, is a very difficult, somewhat complex subject. What you are being studying in your the whole BTech. Okay, so why? Because the problems that you solved in the power system analysis, say for example, power flow problem. Okay, as a solution. So like Gauss-Seidel method, Newton-Raphson method, fast decoupled method. So I think you're going to. I think you already third year students. I think you are studying now, and final year students already studied. Okay, So only thing is that in the classroom you solved only a 3-unit system, or at the maximum you can solve up to 4-unit system. Okay, in the note. So even for solving that 4-unit system itself, taking some half an hour of time. Okay, half an hour to maximum 45 minutes, and all somebody is taking. Okay, so imagine. So in that problem, what we are doing is we are considering certain certain assumptions like okay, so it is like in the initially it is going to be the flat start, and we are converting that to per unit system. Okay, so if you take in a power system operation control in unit commitment problem, we are assuming certain okay assumptions like the load is that the demand is not varying. Okay, demand is not varying in hourly or a minute by minute. So we are considering the demand as some constant demand. Okay, like that we are considering something and going for solving the problem. Okay, so in every power system problem, if you see like some assumptions we are making at the initial. Okay, so even economic load dispatch problem also. Okay, so that is a very complex problem. But what we are doing is we are taking only 3-unit system. Okay, 3-unit system with a fuel cost function, and we are going for solving the solution. We are going for finding out the generating units. Okay, generating units, and also the cost. Okay, what is the least cost generators in that particular area. So that also we are going to okay calculating. Okay, so only for 3-unit system we are solving only 3-unit system. If you go for 5-unit system also, you can solve 10-unit system also solve, but the time consuming is very more. Okay, so if you solve 10-unit system, okay, so if you solve in a note and pen, okay, it will take around 2 hours, 3 hours like that. Okay, so imagine the same system you are going to solve for so 1118 bus system, 30-unit bus system. Okay, like that big bus system. Okay, so I think you may take up to 24 hours to solve that particular problem itself. But we need the solution in load dispatch centers, in generating stations. We need the solution in only like 5 minutes, maximum 2 minutes or 5 minutes. So we need the entire solution. Okay, so if you take the whole bus in and around in Tiruchi region, Tiruchirappalli region, or in and around the whole Tamil Nadu, if you see if you take all the bus system over all the Tamil Nadu, so imagine that might be a very complex problem. Okay, that you are going to solve. Okay, so the whole system, many complexities are there. Even the load, okay, demand minute by minute, it will be changing. Okay, so we are forecasting load forecasting also same. So okay, we are forecasting like, so today's Tamil Nadu's load is around 24,000 megawatt. Okay, so but due to this summer, so that might be changing little bit. Okay, so 500 megawatt it is increasing today. Okay, so many of us are using some ACs or okay ceiling fans, something like that. So today some 500 megawatt suddenly it was increased. Okay, so we have to forecast. Okay, so load forecasting also very okay, so important problem. So in which the input is very more. So we are going to discuss. Okay, so in the load forecasting problem, I think you already studied. Okay, so I want to know the okay, I want to forecast the tomorrow's load. Okay, so 17/3/2013 load. Okay, so 2021 load. Okay, so in that if you take now, so say for example tomorrow's load is of Tamil Nadu is 23,500 megawatt, the whole Tamil Nadu. Okay, so how can I decide like 23,500 megawatt, like based on the previous year load? Okay, and also hour by hour load demand also I need to get. Okay, hour by hour load demand, and also the generator, how many generators is connected, how many thermal generators is connected, how many hydro is connected, how many nuclear is connected. Okay, so in which time this okay nuclear has to be on, in which time okay the thermal generating unit has to be on. So everything I need to predict. Okay, and also in the tomorrow morning 9 o'clock, so what might be the load? Say for example 22,000 Okay, next 9:30, what is the might be the load? I need to forecast based on the previous year load, and also hourly forecast. Okay, and also minute by minute forecast. Also, in some countries they are doing minute by minute. Okay, in every minute, what is the forecast? Okay, so that is of out of the syllabus. Okay, so out of the topic. Okay, so there we need to okay, calculate accurately. Accuracy is very, very important, and also the time taken for calculating that particular thing is very, very important, and also very huge data you need to handle. Okay, so imagine a load forecasting problem, a normal simple load forecasting problem. I'm telling, I'm going to input only about 30 inputs. 30 inputs. I'm going to get the output like only hourly load. Okay, 30 inputs. Okay, 30 inputs if you are giving and solve, if you solve the problem in the node, I think you can't able to get the answer, but even it will take very, very, very more time, very more time to calculating all these things. Okay, so so some system has to be solved, some system has to be, we have to do here some certain programming or some artificial intelligence technique we need to adapt, and that system has to be solved that particular problem very very fastly in a very okay, very less time in a minute. Okay, or some 5 minutes, like that it need to calculate, and it has to give the solution to you, exact solution also very, very important. Okay, so you see, like increase in computational period and accuracy. So even though if you calculate in the node, okay, some accuracy may be missing, and also data handling. Okay, 30 inputs I can't take, and I can't able to solve the problem. Okay, so one input or two inputs I can easily go. So say for example, f of x equal to x square. So what is the value of x, so that f of x is very, very minimum. Okay, so like that, this problem I can easily, simply I can solve. Imagine your practical problem might be of f of x is equal to x square plus okay, 3000 cosecant squared x plus okay, some 10 to the power of 100 into some complex your okay, your objective, your function might be of very, very more, very, very large. Okay, imagine you are going to solve that particular problem. Okay, so I think you can solve, but it will take very, very more time to solve that particular okay, one even if you want to test with the one, say for example x is equal to 2, if you want to test with for okay, very large function, so it will take around 2 hours for calculating that x is equal to 2. So some system has to solve and give the solution. So that's why we are going for this artificial intelligence technique. Okay, so here in the image you are okay, it is showing like a drone. A drone is connecting okay, collecting the images from the substation equipment. Okay, during an EPRI field test. Okay, so EPRI is nothing but European Power Research Institute. Okay, so there what they are doing is they are using this robots. Okay, drones for okay, taking the images in the buses or insulators. Okay, so any faults is happen in the insulators, it can easily see any corona loss is happening in the particular buses. So everything, okay, this drone is collecting the image, and it is communicating to the remote station. Okay, so we can simply sit in a room and you can monitor the whole substation. Okay, so some developing countries like India. Okay, so what they are doing is some okay, field worker has to go to that particular place, and he has to off that feeder. Okay, and he have to check whether what is the fault happening in that particular area. So where the fault is happening, so where this fire fault is happened, so how to rectify that. Okay, so he have to isolate that particular feeder from that system. So many things are there. Okay, so easily nowadays in foreign countries, so they are not even going to near to the transmission line, they are not even going to near to the substation and all. Okay, substation and all in the remote station. Okay, so maybe one member might be there. Okay, simply sitting in control centers, they are monitoring the whole system. Okay, district or some region, state. Okay, everything they are monitoring by simply sitting in a room. Okay, so next, comes the maximum power point tracking. Okay, with the artificial intelligence technique. Okay, so what is maximum power point tracking? Okay, so maximum power point tracking is a function to maximize the energy available from the connected solar module, okay, arrays at any time during its operation. Okay, so we need to extract, okay, it is a function to maximize the energy available from the connected solar PV module, okay, at any time during its operation. Okay, say for example, it is operating from morning 8 o'clock to evening 6 p.m. Okay, or 6:30 p.m. Okay, so we need to extract maximum power from the our solar sun. Okay, so even so, okay, you all know sun is rising in the east and moving towards the west. Okay, so your panel also have to tilt to that particular angle, whichever whatever the your sun is moving. Okay, so your panel has to take the maximum power from the solar, so that only you will maintain the efficiency at the battery. Okay, so here if you see like in the PV generator panel, you can take like temperature of the panel, what is the generation is being happening. Okay, so what is the angle it is being tilted. So everything has to communicate to that particular system, so that the power generation also will be maximum, or otherwise directly you can go for using that load, or otherwise you can convert that okay, DC supply into AC and you can charge the batteries. Okay, so sometimes in the summer hours, okay, so there may be some power deficit, okay, power deficit of 1000 megawatt or 500 megawatt. Okay, so by the time what they will do, simply they will okay, shut down that okay, particular area for half an hour or 1 hour, something like that. So some intelligence system has to simply on imagine now also they are okay, without going there, it is your inverter system is simply getting on. Okay, I'm telling about imagine the battery is connected to directly to your okay, your grid. Okay, so sometimes the battery will be charging to the solar panel, sometimes it has to utilize. Okay, so like say for example, you're staying away from the, you're staying in the office. Okay, so by that time your battery gets charged. Okay, so some message has to be given to you, like your battery is charged, or so your battery is charged, so that power is fed into the grid, something like that. Some messages intelligence system is going to, so you're doing some IoT based projects, no, IoT based projects. Okay, so the communication from the your inverters to your mobile phones. Okay, communication to the grid also. Okay, so same thing is happening in the wind. You are going to install a small wind turbine in your terrace. Okay, you are going to generate some power from out of that. Okay, you are going to connect that power to the grid. Okay, some intelligent power has to be given, so that okay, you can collect the tariff from your electricity board also. Okay, so here we are using one artificial neural network controller, for communicating to that okay, your converter. Okay, so if you are giving some 30 inputs to the directly to your converter, your converter itself will confuse. Either the converter will convert AC to DC, or simply it will calculate what are the inputs coming to that particular converter. Okay, some intelligent system is needed. So here we are going for artificial neural network controller for okay, solving that particular problem, maximum extraction of the power and conversion, everything. Okay, so next we'll move on to the artificial intelligence techniques. Okay, so here if you see like in the artificial intelligence techniques, so there are three major techniques. Okay, so more than that also there. So that is being interconnected with your power system. Okay, so it is easy for solving the power system problems. So the first one is artificial neural network, next one is fuzzy logic system, then optimization algorithms. Okay, so now I am going to discuss in this session, okay, because the time is very short for me. Okay, so as I said earlier, it is a very big like a ocean. I'm going to show you something, okay, in today's session. So maybe in future section, I'm going to discuss this fuzzy logic and optimization algorithm also. So now we are going to see the neural networks. Okay, so what is a neural network? Okay, so according to your DARPA, okay, so this is a scientist, okay, so who was given this definition in 1988. Okay, a neural network is a system composed of many simple processing elements operating in parallel, whose function is determined by network structure, connection strengths, and the processing performed at computational elements or node. Okay, so it is a simple process system operating in parallel, whose function is determined by the network structure, connection strengths, and processing performed at computation elements or nodes. Okay, so it is mimicking your human brain. Okay, so another one definition for this neural network, so that was given by Heiken, 1994. Okay, a neural network is a massively parallel distributed processor. Okay, so like our human brain. Okay, parallel distributed processor that has a natural tendency for storing experimental knowledge. Okay, experimental knowledge and making it available for use. As I said in Google Maps. Okay, so it has a natural tendency of storing some knowledge. Okay, so your Google Map is telling no. So due to some traffic or something like that, your Google Map is telling some different routes. Okay, to follow. Okay, so you have to turn some left and go to some 100 meters, and again you have to take right, and you're following the same path. Something like that. Intelligently, it is telling some path. Okay, so some knowledge system is doing that thing. Okay, so and but it resembles the brain in two aspects. So one is knowledge is acquired by the network, okay, through learning process. Okay, so knowledge is acquired by learning process. So this artificial neural network also will learn. Okay, so due to some traffic or due to some outages, okay, or due to outages in the roads, so it will learn. Okay, so some okay, bridge work is going on throughout some 1 kilometer. So in the knowledge, it is storing. Okay, storing, like, so this bridge work is going on. Okay, so what is the next path you should choose? So something like that, in knowledge is storing. And say meanwhile we are also, say, if say for example we are also traveling in the same path. Okay, so that system is telling, like, so you have to follow the different path because the bridge work is going on. Okay, like that Google also telling. Okay, so due to the some okay, bridge work, so you have to turn left and you have to go straight. Something like that. It is showing some different routes. And also say if you take the Google Maps, it always follows the very shortest path. Okay, so it will not let you go to some okay, some distance path. Always it will follow the shortest path to reach that particular place. Okay, if you are going by walking mode, okay, through Google Maps, it will show exactly the shortest path to go to nearby shops or something like that. If you are going by cycle, okay, yeah, also it will show the very shortest path. Okay, so that is also a intelligent nature available in the Google Maps. That is in the that algorithm, Google Maps algorithm. Okay, so here you say, like, interneurons connection strengths known as synaptic weights are used to store the knowledge as in our brain. Okay, so I'm keeping some okay, pen drive in some almirah. Okay, so I'm forgetting that. Okay, so somebody is asking for a pen drive. So what I'm doing is simply I'm just remembering where I kept the pen drive. Okay, so my synaptic weight is being activated. Okay, so where I kept that pen drive. Okay, so some it will take some time in my for my human brain, not only my human brain, almost. Okay, it will take some time to recollect. Okay, to recollect So that synaptic weight has to be, and that my brain sense will tell like, okay, I kept in this place, you go and take like that. Okay, so that is also the thing is happening in the our human brain. Okay, so this is a little bit comparison between your human brain and your computer. Okay, so the human brain contains 10 billion nerve cells. 10 billion nerve cells are neurons. Okay, so if you see in some YouTube videos, you can easily see in the Nat Geo videos, any videos of that. Okay, on average, each neuron is connected to other neurons. Okay, so if a simple one neuron is okay being damaged in the your brain, so you will be losing some memory. Okay, so some okay injuries happening in your head or brain. Okay, sorry, some injuries happening in that particular nerve or something like that, so you are losing that particular memory. Okay, you can't able to recollect. Okay, so you'll be losing some your writings, you'll be losing some your okay skills, something like that, you'll be losing. Okay, so if you compare this human brain and computer, the processing element, if you take the processing element of human brain, 10 to the power of 14 synapses are there. In computer only 10 to the power of 8 transistors maximum it can act in a time. Okay, so element size, if you take like 10 to the power of minus 6 meters, the same like same element size, even it is very small also. So energy use, so energy used for the brain is 30 watts. Okay, so so students, you are there listening to the classes from morning, okay, to till evening. Okay, so even for so if you listen the class to the classes for 2 hours, you'll get some hungriness. Okay, after some sometimes you want to take some snacks, or and 12 o'clock you'll get severe okay, you'll be feeling hungry by yourself. Okay, so why? Because some energy is utilized by your brain. Okay, so that is of 30 watts. And also simply in if you take like human brain also, like the 30 watts. And processing speed is 100 hertz. Okay, so here the processing speed is 10 to the power of 9 hertz. Okay, so your computer is somewhat faster because we are just thinking, so where I kept that pen drive, where I kept that mouse, like that I'm my processing speed little bit slow. I'm just okay thinking where I kept that okay, that pen drive or like so. But if you just input in your program, okay, so take that value of A. In some nanoseconds, it will give the output. It will give the output. What is the value of A or B, like that? Okay, so that is the, and human brain is got some parallel okay, parallel and distributed processing. Okay, parallel and distributed processing. Okay, so what we are doing is sitting near, okay, near to the TV, in front of the TV, so we are taking our food and even we are listening to music through our okay headphones. And even we are listening what is happening in the kitchen, or what our mom is speaking with, or what our brothers are doing. So like that human brain is doing some parallel processing. Okay, even you're watching TV, you're taking your food, you're okay, you're enjoying your food, you're tasting the food. Okay, you're listening to the music, and you're listening to what others is okay speaking, everything. Okay, everything your human brain. And you also imagine like you're be in some holidays, okay, you're enjoying in some holidays, how it will be like that. So everything human brain is doing multitasking, that is called parallel and distributed. Here if you see like serial and centralized processing. Okay, serial and centralized processing is the, and the fault tolerance in human brain, there is some fault tolerance. Okay, like okay, some say for example immediately a fire accident is happening in front of you. Okay, so human brain can think, okay, how to okay okay get rid of that fire accident, or what we should do. Okay, so that the fire you can stop that firing, like that. But in your programming, it will not think. Okay, so you watch that film, no. So that robot was telling like that is not my that is not being processed to me. Only this is only processed to me. So whatever the thing you program, that work only it will do. Okay, so it is not having any intelligent nature. Okay, so intelligent nature only our brain will give some intelligent thing to that process. Okay, so that's why even though the whole plant, the whole unit of the industry is being controlled by your artificial intelligence, there might be some 3 or 4 employees to monitor that also. Why? Because if any fault is happening, your artificial intelligence will not think to stop that machine. Okay, until otherwise they are not giving any input. Okay, so some members is simply watching that whole process so that they can switch on or switch off that process easily. Okay, and also learning ability is there in the brain. Okay, you can learn. Okay, you are learning, no, the subjects you are learning, no, like that you can learn. But here if you see learning ability also is there based on the memory, and a little bit learning also is there. Okay, so your machine learning, as I said, Google Maps. Okay, AI integrated with machine learning. So little bit learning also it's happening in Google Maps. Okay, so whether to travel in that path or not. So road condition is very worst. You can travel in this road condition, like that. Suggestion also given by the Google Maps. Okay, and also intelligent and consciousness is already there. Usually it is there in the brain, and so intelligent nature is not a, okay. So simply like that, machine learning we are integrating with the AI, and some intelligent nature we are integrating with the our systems. Okay, so if you see like this is the interconnections of the brain. Okay, so there are billions of neurons interconnecting. Okay, this is the picture of how the connections happening in the brain. So this is a simple biological neuron. This is a simple biological neuron. So I think if you studied in a biological group in your 12th, you can easily understand. Okay, so like this is called a dendrite. Okay, wherein which the input is being given. Okay, so whatever I'm thinking, so that the input is being given to this dendrite. Okay, so based on that, it is communicating to your axon. Okay, what you should do for that input. Okay, if I want to take a book, I have to go to a nearby library and take a book, like that. So input is being given to your dendrite, and after processing, it is giving the signal to your axon. Okay, whether to go to that particular place or not. Okay, so imagine same like that. Your neural network also doing. Okay, imagine I'm giving some inputs like x1, x2 up to xn. I'm giving the input, and same like that I'm the output I'm extract. Okay, so whatever the output I need, I'm going to extract y1, y2 up to yn. Okay, so we are going to see. Okay, so and if you see, take like artificial neural network, it has some information processing system. So neurons process the information inside the AI, artificial neural network, and the signals are transmitted to connection. Said that. Okay, as in biological neurons, some connection links are there, and also link possess some associated weight, some weightage we are giving to that particular work. Okay, and also output signal is obtained by applying the activations to the net input. We are giving some activation function. Based on that, our output also we are extracting some output. Okay, so motivation from the neural networks. Okay, so there is some symbolic rules. So symbolic rules. Okay, so predetermined. We are giving some symbolic rules, means whether to perform AND operation or OR operation, whether to perform addition operation, whether to perform multiplication operation. So whatever the rules we are giving, so that is being processed by your neural network. Okay, so but in human brain you can't giving some rules. Okay, like that. So addition, for taking, say for example, I need to lift my phone. So simply like that I'm lifting the phone. There is no some formulas is being fed to my brain and I'm taking that phone. But imagine in your neural network you have to give that formula. Okay, so in what angle your hand has to be lifted, and what angle you have to take that lift that phone, and what angle it has to show in front of your face, something like that. You have to give some rules so that it will lift and it will show to you. Okay, so that is also there. And also massive parallelism is there in ANN, and the distributed representation and computation is there, and a little bit learning ability also there. Okay, so generalization ability is there, adaptivity is there, adaptive to that particular, okay, scenario is there. Okay, so contextual information processing. Okay, that is what information processing. So whatever the input we are giving, so that is being processed in the Google Maps. So if you activate your voice message. Okay, and also fault tolerance also there, some fault tolerance also there, and the low energy consumption. Okay, compared to brain. So you need to feed for your brain. You need to take some, okay, some food for your energy. Okay, like that. So no, so simply like that charging. In the ANN, you have to give simple. So you have to give some charging, and that too very less energy consumption. Okay, so this is a simple artificial neural network. Okay, so imagine only I'm giving only two inputs, x1 and x2. So whereas I'm giving some weightage to that inputs. Okay, w1, w2, and I'm extracting some output y. Okay, so y is nothing but y is equal to x1 into w1 plus x2 into w2. Okay, so I'm telling a simple example. Okay, so that you can easily understand this what is happening here. Okay, so imagine you're going to your home after okay, completing your okay, college work. You're going to your home at evening 5 o'clock. Okay, so after going to your home, what generally we'll do is we'll wash all your hands. Okay, and we'll take bath. Okay, so that is our first input. I'm going to do the first thing after going to the home. I'm giving some weightage for that particular work to be there. So after that, what I will do is I will take a little bit snacks. Okay, so that is the second weightage. So even second weightage, even if you see here W2, I'm giving the second weightage to that for taking the snacks. Okay, third weightage. After that, I want to take some tea. Okay, I'm pre-programming my schedules. Okay, after that I want to take some tea. That is the third weightage. The fourth weightage, what I'm giving is I'm going to go going for some walking. Okay, walking for some 5 kilometers or 1 hour, like that. Okay, that is the fourth weightage. Okay, so like that I'm giving some weightage for that particular work, and I'm doing the work. Okay, so my output is I need to take the cup of tea, or the output is the y is nothing but I need to take a cup of tea, or I need to go for 1 hour of walking. Okay, so I need to listen some music after coming from the walking, like that. So I'm giving some weightage to particular okay, what are the things to be done after going to the home. Okay, so simply like that. Okay, this is the all the things is being added. Okay, summed up here, and it is being given to the your okay, function. This is the activation function. So activation function is whatever you want to do, perform. Okay, either I need to do some addition operation, either I need to do multiplication operation, AND operation, OR operation, XOR operation, whatever it is there. Okay, so your own say for example you're doing the doing some projects. Okay, this activation function might be changing based on their projects, based on their applications. Okay, based on the application, this activation function may be changing. Okay, so you need to move a robot. Okay, move a robot say for example, yeah, one foot like that, you need to move a robot. Your robot has to be walked. Okay, so how it should be walked now? 1 meter, 1 meter. It should okay, two legs has to be action like this, and it have to be moved like 1 meter, 1 meter like that. So what I'm doing is I'm going to program that in the activation function. What the things to be done for that particular robot like. Okay, so what are the inputs I'm giving? Okay, this robot has to do walk, and the robot has to see in front of the image processing also I'm doing. Okay, so so voice recognition also I'm giving as an input. So everything together I'm giving for an activation function. Going to get the output. So my robot has to do all the works. Okay, it has to walk, and it has to listen to the voice, and it has to see the image, whatever is there in the okay, in front of me. Everything it has to process. So this much input I'm giving for processing my robot. Okay, like that. Okay, so this is also a simple. So here if you see like a bias is simply like that. So already I said one example. I programmed. I have to take I have to wash my body, and I have to take okay, snacks. I have to take I have to go for walking. I have to take a cup of tea, everything. So suddenly one bias is coming for me. Okay, some emergency work is coming for me. So okay, so my mom and dad is telling like to go to a nearby shop and get some provisions from the nearby shop, or they are telling to get a tablet. Okay, so suddenly my every some work is being biased. Okay, so instead of walking, what I'm doing is I'm going to nearby shop, and I'm going to done with that particular task given from the whatever the task given to you. Okay, so I'm biasing. Okay, instead of going for walking, what I'm doing is I'm going to nearby shop. Okay, so that is called bias. Okay, so bias is nothing like a weight. So except it has some constant input, and it can also omit it if it is not necessary. Okay, something emergency work is not coming to me means I can simply continue my day-to-day work. I've already given some weightage. So after coming from the walking, I need to study this particular subject. Okay, this power system subject. As like that, I already programmed. Already, it's being given weightage to every work. Okay, so that is also that. Okay, so bias is nothing but emergency work. Emergency work is being given so that it is bypassed. Okay, whatever the work is doing is simply okay, keeping all the work aside, and you are doing that work again. You are coming and doing the same work. Okay, because already pre-programmed. My schedule is pre-programmed. Okay, so that is like bias. Okay, so like if you see like the output I is equal to x into w, that is x1 plus w1 plus x2 into w2 up to xn into w. So activation function, it depends on the problem. Even I'm giving the activation function for doing AND operation or operation or some other operation, whatever. Say for example, I need to square root some values. Okay, I need to integrate some values. I need to differentiate some values. Okay, so I want to know what is the best mobile phone that is available in the market for some budget. Okay, so what I need to do is I need to differentiate. Okay, I need to input what are all the companies, what are all the models, okay, that is available in the market. Okay, I'm giving the weightage to that each and every company. iPhone, I'm giving weightage as 1. Next is I'm giving the weightage to some Samsung. Third is Realme. The fourth is Redmi. So something like that. I'm giving the weightage to particular company. I want to know which is the very best phone for me under 15,000 rupees or under 20,000 rupees. I need to purchase a mobile phone. So based on that, you can also program your things. Okay. So next, I'm going to give you a very simple example. So x1 and x2, I'm going to input. Okay, so weightage I'm here, I'm giving is 0.7, W2 as W1 as 0.7, W2 as 0.7. Okay, so here I'm going to add. Okay, add. So what is my threshold function is? Threshold is 0.5. Okay, so only threshold is nothing, but after that it won't allow. Okay, so only the allowed value is only 0.5. Okay, I'm inputting x1 as 1. Okay, so 1 into 0.7 is 0.7. So here also I'm inputting x2 as 1. So 1 into 0.7, 0.7. So 0.7 plus 0.7, 1.4. Okay, so 1.4 I am giving to some activation function. Okay, some activation function. So next is my threshold function is only 0.5. Okay, so only 0.5 means it will not allow. Okay, so maximum, say for example, the activation function I am giving f of I is equal to 1. Okay, so here what I am getting is only what I am getting is 1.4. 1.4 as an output. Okay, so that is I. So 1.4 is greater than my threshold. That is 0.5. So this function is correct. Okay, so this will do like so. F of I is equal to 1 if I is greater than or equal to threshold. So simply like that, this condition is satisfied. Okay, so if it is not satisfied, this threshold it will not follow. Okay, so it is greater than 1, greater than or equal to greater than 1, greater than 0.5. Simply like that, this okay function is being activated. Okay, another one example also I'm telling. A neural network function has to perform one OR function. Okay, so OR function, if you take like, okay, so what is the OR function? So just like that, you need to add. Okay, so if 0 plus 0 is 0. Okay, 0 plus 1 is okay 1. 1 plus 0 is 1. Then 1 plus 1 is 1. Like that, that is the OR function. Okay, so here this is the input. The x1 and x2 is input is being given to the system. Okay, so what is W1 and W2? W1, W2 here I am taking as 0.7. Okay, so my threshold limit is only 0.5. Okay, so here what I am doing is I am performing x1 into W1. So that is 0. Okay, so here x1 into W2. X1 into W2 is W1 is again 0. Okay, so here x2 into W2 is 0.7. So here, so simply like that, I am adding, I am just multiplying the weight from this. So what is the activation function? So if you take the activation function, so I is equal to x1 into W1 plus x2 into W2. Okay, so this plus this. Okay, 0 plus 0 is 0. 0 plus 0.7 is 0.7. Here 0.7 plus 0 is 0.7. Here 0.7 plus 0.7 is 1.4. Okay, so threshold what I have given is 0.5. Okay, so here if you see like threshold is less. Okay, threshold is less than okay 0.5. Here 0.7 is greater than okay 0.5. Here 0.7 is greater than my threshold value. Here 1.4 also greater than my threshold value. So what is the output? One output is being given now. So based on the threshold, the output also is being given. Okay, so for here it is taken as 0. So it is greater than 0.7. Okay, so greater than 0.7. So simply like that, I am taking the output as 1. Okay, so greater. So the condition is greater than 0.7 means it has to take 1. Your activation function has to take 1. So here I am taking the output is 1. See, similarly for 1.4 also greater than threshold, so I'm getting the output as 1. Whereas here I am getting as 0. Why? Because it is less than threshold value. Okay, so like that, so many examples are there. So AND function. So AND function also same. So AND function simply like that, you are multiplying. Okay, multiplying same. Okay, so input is being given. Okay, same weightage. Okay, so you can also solve. You can take down this problem simply like that. you can also solve in your home. Okay, so AND function. Similarly, the AND function also the following. So here the AND function, what I am taking is this threshold value. Threshold value I am taking from 0.7 to 0.1. Okay, 0.7 is the threshold value should be between this 0.7 and 1.4. So within the threshold value, it should be activated. Okay, something like that I am taking. Okay, so imagine the second neural. This is some example. It's the same OR function with bias. Bias I am taking here as minus 0.2. Okay, so bias means, so whatever the value, say for example 0 into 0.7 into 0 into 0.7, so minus 0.2. So I am taking the bias also here. Okay, so bias also here, and I am going for the output. So if you take like minus 0.2, so this is 0, so this is 0, so 0 minus 0.2, 0 minus 0.2 is minus 0.2. So here if you take like some answer you will get. Okay, this is this is 0 plus 0.7 minus 0.2. Okay, so that is 0.5. So based on that output you need to decide whether it should be 1 or 0. Okay, so based on the bias value. So bias also it is being given in this example. Okay, same like that in example 3 also same. Okay, so you have to find the response of region for AND function with the weightage as W1 W2 as 0.5 and bias is simply is given like minus 0.6. Okay, and the threshold is 0 here. Okay, threshold is 0 here. So you can take down the simple problem over here, and you need to calculate what is the output. Okay, so if you just calculate the output here, I'm getting like 0.4 minus 1.0 minus 1.0 minus 6 like that. Okay, so the activation function, how I input is like, if it is greater than 0, greater than 0, it has to come like 1. So if it is minus 0.1, it should be 0 here. Okay, it is minus 0.1, it should be 0 here. So simply like that, many things are happening over here. Okay, so here if you see like response the same like that. So this is one example is being solved over here. Okay, so simply like that, the 0.5 into x1 plus 0.5 into x2. So 0.5 into, so minus 0.6. So 0.5 into x1 is 1, 0.5 into x2 is 1. Okay, so 0.5 plus 0.5 is 1. Okay, so minus 0.6 is 0.4 here. Okay, so based on that, so output also meanwhile the output also is getting for me. Okay, so next is weight and bias updation. Okay, so next is so I think it's time. Okay, so weight and bias updation. Okay, so updating the weight and bias even per sample, or even like each and every iterations. Okay, so each and say for example, if you want to do imagine your robot wants to do a particular operation. It has to travel to 1 kilometer. Okay, it has to travel to 1 kilometer. So simply like that, your robot is being traveled for 0.5 kilometer. Okay, so it is traveling one feet like that. One feet it is traveling. One foot it is traveling. Okay, so remaining 0.5 kilometer is that. Okay, simply like that in every epoch, every iteration. Okay, it is being updated. Okay, so what is exactly exact place your robot is placing. So again your 0.5 kilometer is there now. So again it is moving to some 0.6 kilometer. So 0.6 kilometer, it is updating the distance to that destination. So again it is traveling some 1 foot. Okay, so again it is updating with your destination. Something like that. It is keep on updating so that your solution might be reached. Your destination might be reached. Okay, so and also there is some stopping condition. Okay, there is some stopping condition for that particular algorithm. Okay, so all change in weights, if you see like all change in weights in previous echo is below some threshold value. Okay, we are giving some stopping condition for that particular neural network. Okay, if the all weights is okay being satisfied with some threshold value, then simply you have to stop that particular algorithm. Say for example, if your robot reaches that particular 1 kilometer, you're programming your robot to walk for 1 kilometer. Your robot is okay reaching that 1 kilometer. So after that, simply it has to be stopped because you are programmed like that. Okay, there is some stopping condition. You have to give some stopping condition, or otherwise simply like that your robot will keep on walking even for 100 kilometers also your robot will walk. So that you have to give some limit, okay, so that your robot is being stopped or something like that. Okay, so and also percentage of samples misclassified in the previous epoch. Okay, so based on the previous epoch, so if something, yeah, if say for example, if your robot is traveling in some wrong direction, so that also being updated because each step your robot is updating. No, so every foot, your robot is updating with your artificial intelligence system. So your artificial intelligence will give the input like you are traveling the wrong path. So you have to turn left a little bit, left. You have to travel in a straight line like that. Your intelligence is giving the input to the particular thing, and also number of epochs might be expired. So you are giving the input like that robot has to walk, the distance 1 kilometer. So one foot means some 100 foots it has to travel to 1 kilometer, like that you are inputting. Okay, so after that 100 foots, it will simply stop because it has reached the maximum iteration, that is maximum steps. After that, simply it will stop. Okay, so that also you need to program correctly. And also in practice several hundreds and thousands of epochs. Imagine I am telling like only 100 foots or something like that. So in your practical problem it may be vary. Your artificial intelligence program may be vary. That program has to run for 10,000 times or 1 lakh times to get the best output, something like that. Okay, so even if the input is more, okay, for Google Maps, your users are more. Okay, how it is handling? Even crores and crores of customers, it is handling in a minute. Okay, so that AI is okay. So in headquarters, one artificial intelligence system is managing all the users. Okay, all the users. So imagine it is very complex problem, but even though it is managing, your artificial intelligence system is managing all the users. So AI is giving the solution to that is Google Maps is giving the solution to all users in the world, throughout the world. Okay, so like these are the building blocks of neural network. So that is the connection network architecture, and you have to set the weight, and you have to set the activation functions. So everything you need to set. So these are the building blocks of AN. Okay, so these are the different types of okay. So AN. So first is single layer feed forward network, multi-layer feed forward network, fully recurrent network, competitive network, Jordan network. Okay, simple recurrent network. Okay, so if you see like a single layer network, okay, so information. So information is traveling. Information that is passing in only one direction. Okay, you see like a single layer network. So in fully multi-layer network, if you see like some hidden layer also there. Okay, so whatever the input you are giving, it is traveling to hidden layer. From the hidden layer, it is directly being connected with the output layer. And if you see like fully recurrent, these are the different okay like networks that we followed in your AN. Okay, so based on the application, you also choose your own networks, so that your application solving the application might be very easy. Okay, if you take like this fully recurrent network. Okay, so this is bidirectional data flow is happening in the fully recurrent network. Okay, so if you see like this competitive network, so competitive network, if you see like output nodes try to compete with your each other. Okay, so if you take like after output is being competed with each other. Okay, to represent the input pattern. So that is the competitive network. Okay, so if you take like Jordan network, the feedback from the net output is given to the input. If you see like feedback from the net output is being given to the network. And if you see like a simple recurrent network, so after going to the hidden layer, again that information is being transferred to some context layer, context unit. So again, it is copied back to the hidden layer. So again, it is given to the output. Okay, so I already said based on the application, you have to choose your own network, and you have to program for that particular whatever the things you want. You can easily program. Okay, so without that, your AI is not possible. Okay, so next is layer properties: input layer, hidden layer, output layer. So input layer, if you take like each input may be designated by some attributed value. Okay, as I already said now, say for example, I need to take this mobile phone. So you have to give me one input. Imagine I'm an ANN. I'm an intelligent system. So someone has to give the input. Even I will be programmed like if I give one, I have to lift my hand like this. Okay, so if I given the input like 2, I have to take my mobile phone. Okay, if the input is being given like 3, I have to lift my hand in front of me. Like that, I'll be being programmed. So based on that, one each attribute values also will be given to the layer input layers, and also hidden layer. So if you take like this hidden layer, this is optional. You can go for hidden layer or don't go based on the application. Okay, so it is not directly observable, and it also provides non-linearities for the network. And also, if you take like output layer, it encode possible values. Okay, so whatever the output, so it can encode. It can encode, and it will give the possible output to the output layers. Okay, so there are some 3 training processes are there. Okay, so first one is supervised, unsupervised training, and reinforcement training. So in supervised training is like teaching with a teacher. Okay, so teacher is coming to the class and is teaching like how to draw a letter A. Okay, so teacher is teaching you how to draw a letter A. So that is called your supervised learning. Unsupervised learning, what you are doing is by seeing letter A, yourself you are learning. Yourself you are learning to put that letter A. Okay, so that is called unsupervised learning. So reinforcement training is nothing but, so that system itself will tell you like whether it is right or wrong. So imagine in your COVID time and all, you are answering by your for multiple choice question. Okay, so like a true or false question is being asked now. If you click like true in Google, okay, and Google Sheet, if you activate, if you give that answer also in that, if you click like true, even though that answer is wrong, it will simply show like to change the answers like that. Okay, true or false. Okay, so some intelligence is given to the thing whether you are going in right direction or wrong direction. Okay, like as I said, no, your robot is following some path. Okay, line following robot. Your robot is following some wrong path. Okay, so there the intelligence system is giving the command to that robot whether that path is right or wrong. So if it is right, it will be travel in the same path. If it is wrong, it will give the command to AI. So AI will command to that particular robot to travel in right direction. So that is called reinforcement training. Okay, so there are some activation functions. Okay, so if you see like types of activation, the identity function. Say for example, f of x equal to x for all the values of x. So if whatever the value of x is being input to that particular value, so that will give you the output. Okay, so if you see like this identity function, it will be like a linear function. Okay, it is linearly varying. If you just try with some examples, okay, if you take this as a take after your home, you can also simply like that you can solve. Okay, if you see like binary activation function, okay, so binary activation function will be like f of x equal to 1 if x is greater than or equal to 1, if it is 0 if x is less than or equal to t. Okay, that type. Okay, so based on that, it will be like either it is 0 or 1 based on the input. So if you see like bipolar activation function, okay, so bipolar, name itself bipolar. So f of x equal to 1 if x is greater than or equal to t, or minus 1 if x is less than or equal to t. So okay, so if you see the output, if you see the output here, okay, so simply like that, it is minus 1 if it is x is greater than or equal to sorry, less than or equal to t, if x is equal to 1 if x is greater than or equal to t. And sigmoidal function also there. Similarly, binary sigmoidal function, then bipolar sigmoidal activation function. Okay, so imagine you no need to go for the same activation function. So these are the predetermined activation function being available in your neural network. Okay, so you have to choose whether which category your activation function is falling, or otherwise you can go for your own activation function. There is nothing wrong in that. Based on the application, you can choose your own activation function. Okay, so if you see like binary sigmoidal activation function, it is f of x equal to 1 by 1 plus e to the power of minus x, something like that. This activation functions might be like this. So binary sigmoidal function also has some activation function. Okay, so sometimes it may be discrete, sometimes it may be continuous. Okay, so you have to choose you want discrete function and or continuous function. So constructing ANN. Okay, so you need to choose the network topology, the types of connectivity. So order of connection you should choose. The weight ranges, as I said now, weight ranges. Which is the first weight you need to give, you are giving. So first is walking. Walking means you need to give the weightage to for walking. So after that, it has to process the image. So second weight. After that, it has to do some work. Third weight. So like that, you have to give the weightage and also activation ranges. Activation ranges. Then schemes, initialization schemes, learning rules. Which learning rules it has to fall around? Okay, whether it is supervised learning or unsupervised learning or reinforcement learning. So that learning rules also you should follow. So simply like that, you have to choose the suitable neural network based on the problem, and you have to construct based on the characteristics of the problem. You have to train that neural network because your robot has to walk, no? So you have to train that neural network in pre-op, and with that learning procedure, you have to select a model. Okay, I said now some models. In that model, which category you want, you need to select the suitable model, and you have to make for the solving the your problems. Okay, so this is all the same. Adjusting the weight. Okay, and the classifying the training data testing, and okay, so unknown data, and also neural network needs a lifelong time for training. Okay, so just like that, it will not simply stop or stop its training. It will keep on training. Why? Because it practical problem will come. Okay, so say for example, demand low demand, might be changing like anything. But the input what we are given, like based on this demand only, how to how to switch on the which are the generating units you need to switch on, like that only we program. But we don't know the practical problem, and it may be changing like anything. So based on that, your AI also has to react. Okay, so like that, the training is very very important in the neural network. And also neural network has high tolerance, and high tolerance to noisy and incomplete data. Okay, so you are giving some incomplete data or noisy data. Sometimes your neural network won't works. Okay, so you have to give either 1 or 0. Okay, so based on the threshold value. Okay, so whether your robot has to walk or it has to stop. Okay, or otherwise some threshold is coming or some bias is coming, it has to stop. Suddenly a bias, some noise is coming, some disturbance is coming. So simply like that, your robot has to stop that particular area. So something like that your robot has to do. Okay, so salient features I already discussed. Adaptive learning, self-organization, it can use for real-time operation, and also fault tolerance also there, because it is learning, no? And massive parallelism is there. Okay, and distributed representation is there. So these are the some of the applications of ANN overall. Okay, so it is you know, ANN in this neural network is used in artificial intelligence. Okay, computer science, your mathematics, solving some complex mathematical problems, even very complex mathematical problem also you can solve by this AI techniques, optimization techniques you can solve. Then some dynamical systems you can solve non-linear problems. Okay, so you take all the things are non-linear problems, linear problems easily you can solve it with your AI. Then engineering problems, image processing problems, that is very very important. Image processing problem. Okay, so if you are giving some cancer, cancer images, cancer treated images to signal processing through your neural network or AI. So it has to detect whether that that case is having cancer cells or not. Okay, and sometimes cancer cells may be very very minute. So that also that AI has to learn, and it has to give the output. Okay, it has to give the output how it is being given, or how what is the stage of cancer. It is in stage 1 or stage 2, stage 4, like that. The output also have to be get okay. And also for robotics, I already said, even it is used in the predicting your stock market, finance for stock market. So how the prediction might be tomorrow, what is the stock market, what is the NSE, okay, what is the Sensex tomorrow, like that also it can go for prediction option. Okay, so stock market, if you see, like, it is not a very easy problem that you can solve in Node. Okay, so even minute by minute, based on the shares, it may be changing. And also predicting the share market also. So in morning news, you are seeing, no? So the shares approximately it will be in this range today. You can buy this shares, like that. So how we can predict? No? Simply like that. We are going for this artificial intelligence technique only. Okay, and linguistic, okay, speech recognition, and cognitive psychological recognition, neurobiology. So there are many applications are there, not only this. So this something I have shown here. Okay, so this is the load forecasting problem what we are really solving in our power system. Okay, so load forecasting problem, you can simply tell like you can forecast load on previous year, like that. You can simply tell. Okay, so if you really go to that particular problem and solving that problem, so input may be of, so I have taken a simple load forecasting problem. In that itself, I am having 30 inputs. Okay, 30 inputs. Some network has to, some intelligent system has to process and I want only one output. One output means exactly at this time next year. So tomorrow morning 9 o'clock, what might be the load of the whole Tiruchirappalli region? Okay, so even if you take like input, so I need to take the hourly load of the day of the previous year of the Tiruchirappalli region, and that too area wise I need to take. Okay, so and feeder wise, substation wise I need to take, and also the temperature, maximum temperature of that particular system. Okay, some generating system, minimum temperature, average temperature of that particular PV solar system, that I have to need to take. What is the humidity today? Okay, that I need to forecast. Okay, so based on the humidity, I need to go for forecasting of water range available in the dam, so that I can on hydropower station. Then your wind speed. What is the wind speed exactly today in that particular region? Longitude and location I need to locate, so that I can go for maximum power generation. Okay, and which day I need to take, and what is that day? Say for example, if it is a festival day, I need to go for special forecasting. Like that, many things are there. Input, not only 30 in this system. I have taken like 30. If you go for practical problem, if you stand in load dispatch centers, and if you forecast that particular problem, so this 30 might be of 60, 100, like that. So imagine 100 inputs. It is not very easy task you to process. You can't simply think your brain can't simply think like inputting 100 inputs, and by taking the output, one output, or 24 hours load forecasting I need to get based on this. Okay, so simply like that, it is a very complex problem. But your neural networks can simply do like that. If you train the neural network like that, your neural network can train, and it will give you the hourly forecast. Okay, so 9 to 10, what is the forecast? 10 to 11, like that. Simply for 24 hours, I can easily get the forecasted output. Okay, simply like that, one click. If I wait for 1 minute or 2 minutes, simply like that, I can easily get the 24 hours forecast. Okay, so my job is very, very simple with my AI system, neural network system. Okay, so you can go for fuzzy logic, and you can go for optimization algorithms also. That I will discuss in the next next session, if possible. Okay, so and if you take like smart grid. Okay, smart grid also very, very important problem. Okay, so what is a smart grid? Okay, yeah, smart grid is nothing but a electrical grid with automation, communication, and IT system. Okay, so that can monitor the power flow from points of generation to points of consumption, and also controls the power flow. Okay, so it has to monitor the power flow from points of generation to points of consumption. Okay, and also it also controls the power flow also through some intelligent system, some communication, internet. Okay, or some IT system, Wi-Fi or IoTs. Okay, or your GSM technology, or your Li-Fi, like that. It has to something. It has to connect with some technologies. Okay, so what is the need of this smart grid? Okay, smart grid. So entire thing, even your if you see in the image, nuclear power plant is connected, factories are connected, thermal power plant, hydropower plant is connected, electrical vehicle charging station is connected, wind power plant is connected, solar PV cells is connected. Even your our load also get connected. Okay, through a control center. Okay, simply by sitting in the control center, you can simply monitor every system. What is the hourly load? Even the demand is increasing now. Which station you need to touch? Which least cost generating unit you need to touch, so that your operating cost will be very, very minimum. Okay, so like that also you can go for simply like that. It is all possible by your smart grids. So that's why they are going for smart grids. So in your information technology plus your electrical technology, and also even the fault analysis also very easy in the fault smart grid. Okay, so whatever the existing the bulk grid system, okay, so say for example nearby your home some fault is a line to ground fault is happening. Okay, so simply like that, if you call to your lineman or your electricity board, they will tell like we'll come in half an hour or 1 hour, like that. They will come after half an hour or 1 hour. Okay, so imagine that whole area will not get that power for 1 hour or half an hour, like that. Okay, so until otherwise that fault has to be rectified. Okay, so say they have to simply go to the pole and they have to replace. Okay, they have to connect that particular two wires, then they have to feed that feeder, like that. So it will definitely take 2 hours or 3 hours. Okay, if line to ground fault happens. Okay, so in smart grid, what it is happening, fault analysis also very easy, and your robot is doing all the things. Okay, so one robot, what we are doing is we are sending through the line itself. Okay, so simply like that, the line following robot is traveling throughout that transmission line. Even some fault is happening now, it is simply connecting the two wires, or some insulator failure is happening, or some in your terminal some fire accident is happened. Simply like that, in robot itself, we are commanding, we are giving the command to your robot itself. So your robot is doing all the things simply by sitting in the control system itself. I'm able to rectify whether which okay, circuit breaker I should on, which okay, control panel I should off, something like that. Everything I'm getting the input and output. I'm whatever the operation I'm doing from my control system itself, control center itself. Okay, so you can see, so all your loads is communicating via some Wi-Fi. Okay, even some buildings, even electrical charging station, even generating station, everything is connecting. Okay, so fault clearance also will be easy, and also you can okay, you can reduce some generation system also. Okay, so even you know which system is better. So based on that, okay, so you can optimize the load power generation also. Okay, so if every system is connected, and also you can optimize the line losses also. So whichever the line losses is more, so in that system you can concentrate and you can try to reduce that particular line losses, so that you can get maximum efficiency, and also the cost is also going very lesser. Okay, so this is how. Okay, so even some drones and robots. Okay, so insect size robots also identify the faults, failures, and it is easily inspecting, and it is giving the signal to control station whether what to do, like that. So simply from the control station itself, I can easily give the command to that particular lineman or to particular feeder, so that they will go and rectify the fault. I'm giving the solution also by sitting in the control center. Okay, what to do and what to not to do. Okay, so the field worker, so time taken by the field worker is very less. So field in the normal existing system, what we are following in our country, so someone have to go, they have to intelligently think, they have to rectify. It will take some 3 hours, 4 hours. So simply like that, I'm sending a line following robot, insect size robot, robot itself commanding to me. Okay, what to do and what to not do. Okay, simply like in control center, I'm just turning on the feeder or turning off that feeder. And also smart metering also one of the important factor in this smart grid. Okay, so even one worker has to go to every house, and he has to take that reading. Okay, and he has to calculate that, even though that machine is calculating, but he has to update in that machine. Okay, in the smart meter, simply by sitting in the whole in the control center itself, I am able to monitor that. Okay, whatever the energy consumption in the particular domestic load or okay industrial load, like. Okay, based on that, I'm giving the power factor tariff. I'm going to give the penalty to the industrial customers. Like that, simply, my job is very, very simple. Okay, the future power system engineer job is very, very simple. Okay, so by sitting in the one room itself, I can able to control 100 kilometers, 200 kilometers apart. Okay, same like that in wind energy conversion system also it is happening. So I'm going to input turbine speed, wind speed, pitch angle, okay, temperature of the okay, bearing, turbine bearing, gear oil, okay, stator temperature, generator voltage, current, everything I am going to input to a one neural network, adaptive neuro-fuzzy interface system. So I already told, instead of going for fuzzy system, you can neural system. You can also go for your optimization algorithms. You can also go for AI techniques. Okay, some other AI techniques also. This is a simple example. And output, what I am going to get is the health index. Okay, so whether the wind energy conversion system is excellent, or it is good, or very good, or it is fair or poor. So diagnostic message also I'm getting. So your generated temperature is more, better you off that particular wind turbine. Your particular location, wind speed is very, very less. Okay, instead of 45 kilometer per hour, what I am getting is only 10 kilometer per hour. Okay, so better to off that particular turbine, like that, off that particular turbine number 5, turbine number 10, turbine number 100, like that. I am getting the diagnostic message also to the control center. So what I'm doing is one click, I'm going to off that particular wind energy system. That is what happening in our system also. Okay, so in remote station they are sitting through PLC SCADA, they are communicating. Okay, so thank you very much. These are the reference in which I have referred for this. Okay, so thank you very much. Okay, for your kind patience. Okay, so you can take my email address, mobile number. You can contact me at any time. Okay, simply like that. If you give an email, I can even help you for your projects also. Okay.
Students, the feedback is being posted in the chat box. Kindly fill the feedback. Then now it's time to propose a vote of thanks. It's my privilege to thank Dr. R. Vijay, Associate Professor in the Department of Electrical and Electronics Engineering in CVR College of Engineering, Autonomous Institution, Hyderabad. Sir has been delivered excellent content on the topic of recent trends in artificial intelligence and its applications to power systems. He has been covered almost all the applications where AI, that is, he has been given the introduction about power systems and artificial intelligence. What is the need of artificial intelligence in power systems? Then he has been covered the maximum power point tracking, then about bias and weight, then layer properties. Then he has been went into the salient features of ANN, then applications of ANN. He has been discussed about the forecasting, load forecasting, as well as the happenings, the real scenario in the load dispatch center. Then he has been, at the end of the presentation, he has been proved that artificial intelligence, if you implement artificial intelligence, it can improve the smart grid, very smarter. Then he has been covered where that is AI techniques in wind energy conversion system as well as in solar. That is almost he has been covered all the applications. Thank you very much, sir. Under his busy schedule, he has been accepted. Yes, thank you, sir. Under his busy schedule, he has accepted to deliver this wonderful topic. Thank you, sir. Thank you once again. If you have been the lockdown period, he has been closed down entirely. Then if you will invite sir to come in person to give a workshop on this title so that students can learn using simulations. So this AI can be implemented Yes.
Even I try to plan for solving certain problems also. Even if it's in offline,
Yes, sir,
these
it's-
students also can solve a little bit problems. Okay.
Yes, sir.
Situation-
If it is, yes, yes, sir. Small projects we can train, sir. If it is in offline, it has been very good. The online,
Yeah.
that is, we cannot be able to.
Online.
The students were exactly they are being getting trained. That is the difficulty, sir. Here.
Yeah.
Okay, sir. Next, we will invite once again, sir, in physical manner. We will meet. Okay, sir. Okay. Thank you very much, sir. Thank you. Thank you.
Thank you.
Thank you.